science. Welcome back again for our nuclear chemistry activity today. And we are going to be completing the classroom activity, which is a demonstration of the radioactive decay of an element called americium. Americium, yes, americium. And so I'll explain to you what it is we're going to do here. By the way, disclaimer, do not try this at home, please, okay? If you can't promise me you won't try this at home, stop the video, don't watch anymore. Don't try this at home. Every one of you at home should, however, have one of these. Do you know what this is? This is a smoke detector. And smoke detectors, believe it or not, have radioactivity inside of them. In fact, I'll see if your camera can pick this up. You see what it says there? Contains radioactive material, americium-241. Americium-241. Americium-241 is a radioactive element. And by the way, it's measured in a unit called picocuries, and it is a very, very small concentration. 1 picocurie of americium-241 is contained in this smoke detector. Never disassemble a smoke detector. But if you did, this is what you would see. The guts of it, its electronic guts, contain this structure here, which is a protective casing for the radioactive substance, americium. I've actually, for scientific purposes only, have removed some of the americium from my smoke detector, which no longer works. And we're going to do something with the americium-241 that I have removed. So what are we going to be doing with it? Well, on page 176, there is a graph, and the graph looks like this. On the x-axis, I'd like you to label it distance in centimeters, starting with 0 up to 8 centimeters. So that's a pretty small distance from 0 to 8 centimeters. We're going to be using a ruler in this little activity to show this. And over on the y-axis, I don't know if you can make this out, but it's the estimated clicks per second from 0 to 8 clicks per second. And once you have this graph prepared, I'm going to be placing a Geiger counter on the screen and some americium. And I'm going to move the americium closer and farther away to the Geiger counter. And we're just going to estimate how many clicks per second we hear using the Geiger counter as an estimate of how strong the release of alpha particles are from the americium. You remember what alpha particles are? They're the weakest form of radiation. That's why I'm wearing my gloves to protect my hands from the americium, from the alpha particles emitted here. And I'm just doing this in very small doses. And it's why I'm doing it and not you. All right, so hopefully you have your graph drawn. And I'm going to show you the americium now. These are the little sections of americium that I have removed. It's just a small sample of metal within this case, and that is radioactive americium. And I've got a few here in case I have a duck. This is my Geiger counter. And I'm going to place my Geiger counter over here on this side, just like this. And I'm going to place the ruler. Oh, it's upside down. Let me turn this around. Let's see. So we've got your ruler. We've got the Geiger counter. There we go. And we've got the Americium. I'm going to move it a little bit further away for the time being. And so I'm going to turn our Geiger counter on, and we're going to hear it. Now, I don't know if the camera is strong enough to pick up the clicks. Hopefully it is. Hopefully you'll be able to hear the clicks on the video here. If not, I will share the observations with you. So here it is. Actually, you know what? Here's what I'm going to do. I'm going to turn our Geiger counter on just in case you can't hear it. I'm going to hold it closer to the microphone. Hopefully you could hear those clicks. Okay. Hopefully you could hear those clicks. Okay. So here we are with our little demonstration with our ruler, Geiger counter, and Americium. Now, be aware that there's always some background radiation that we are exposed to, folks. So every so often, you might hear a click, like I'm hearing a click periodically right now, maybe every 15, 20 seconds or so, because we are exposed to background radiation all the time. But we're most concerned with this Americium. So we're going to move it to 10 centimeters now. And I've got a few chunks of the Americium here. We're about 10 centimeters away, and we're barely detecting anything, although it is increasing a little bit. So I'm going to move it to 8 centimeters. Still not very much. It's less than 1 per second. I'm going to move it to 7. And I'm hearing it, about, on average, about once per second. About once per second. Go to 6. Still about once per second. Ooh, a little bit more now. At 5, that's probably about 4 per second at 5. At 4 centimeters, I don't know if you can hear that clicking. I'm going to estimate about 10 clicks per second. At 3 centimeters, that's a lot more. We're going to estimate about 40 clicks per second. And let's go all the way to 1. Oh my goodness. I don't know if you can hear that, but it's complete static. That's got to be, wow. That's got to be well over 100 clicks per second. So you know what? I'm going to turn this off, put the Americium away, and we're going to modify your numbers on your graph. On your y-axis, add a 0 to these numbers. So it should be 10, 20, 30, 40, 50, 60, 70, and 80 plus. And use the numbers that I gave you. Hopefully you got those numbers. If not, watch the video again. Plot your dots for those numbers and check out your graph. See what kind of graph you end up with, and that tells you something about the intensity of radioactivity and the distance away. By the way, I'm going to do one more thing here. I'm going to go back to the blue screen here for a moment, and I'm going to turn the Geiger counter on again, put the Americium close to it, and then put a piece of aluminum foil between the Americium and the Geiger counter and see what happens. So let's check this out. So here's the Geiger counter. Here's the Americium. Hold on, let me turn this around here. All right. It's clicking like mad. Hopefully you can hear that. Now I'm going to take the foil. The clicking disappeared. Let's try it with some paper here. Here's our massive clicking. And the clicking markedly goes down with paper. Let me fold the paper a little bit. Try this again. Oops. I need another hand. Let's try it again. So here we have the clicking. And the paper pretty much stops the clicking, which means the paper, is a good blocker. And certainly the aluminum foil is even better of the alpha particles coming out from that americium. The bottom line, folks, as far as your safety is concerned at home, you put these smoke detectors out of reach, right? It has a protective coating in there. No radioactivity comes out of your smoke detector unit. These will save your life in the event of a fire. Don't worry about the americium radiation coming out of them. You get a lot more exposure to radiation by having your cell phone next to your ear than you do from a smoke detector. So smoke detectors are good things, but it's the americium in there that enables them to do their job. Hopefully you had time to finish this little activity up. And so study for your quiz tomorrow. And until then, bye-bye.